A very good morning, sir. I'm Y Nikita from EC Department B section. My roll number is 21951A04C2. My concept video topic is Ohm's law at constant temperature. According to Ohm's law, the voltage or potential difference between two locations is proportional to the current of electricity flowing through the resistance, and the resistance of the circuit is proportional to the current or electricity traveling through the resistance. V is equal to IR is the formula for Ohm's law. George Simon Ohm, a German physicist, discovered the connection between current, voltage, and relationship. Let's take a closer look at Ohm's law, resistance, and its applications. Voltage, current, and resistance are the three most fundamental components of electricity. Ohm's law deposits a straightforward relationship between these three variables. According to Ohm's law, the current flowing through a conductor between two locations is proportional to the voltage across the conductor. This is one of the most fundamental electrical rules. It aids in calculation of an element's power, efficiency, current, voltage, and resistance in an electric circuit. V is proportional to R. V is equal to IR. V is the voltage, I is the current, and R is the resistance. According to the Ohm's law, the voltage or potential difference between two locations is proportional to the current of the electricity flowing through the resistance, and the resistance of the circuit is proportional to the current or electricity traveling through the resistance. V is equal to IR is the formula for Ohm's law. George Simon Ohm, a German physicist, discovered the connection between current, voltage, and the relationship. Let's take a closer look at the Ohm's law, resistance, and its applications. More specifically, Ohm's law states that the R is the relation is a constant independent of the current. If the resistance is not constant, the previous equation cannot be called as Ohm's law, but it still can be used in the definition of the static or DC resistance. Ohm's law is an empirical relationship which accurately describes the conductivity of the vast majority of electrically conductive materials over many orders of magnitude of current. However, some materials do not obey Ohm's law. These are not called ohmic. The law was named after the German physicist George Ohm, who in a treatise published in 1827 described measurements of applied voltage and current through a simple electrical circuits containing various lengths of wire. Ohm explained his experimental results by a slightly more complex equation than the modern form above. So, Ohm's law is an empirical relationship which accurately describes the conductivity of the vast majority of electrically conductive materials over many orders of magnitude current. However, some materials do not obey Ohm's law. These are called non-ohmic. Ohm's law is an empirical law, a generalization from many experiments that have shown the current is approximately proportional to the electric field of most materials. It is less fundamental than Maxwell's equations, and it always not obeyed. Any given material will break down under the strong enough electrical field, and some materials of interest in electrical engineering are non-ohmic weak fields. Ohm's law has been observed on a wide range of length scales in the early 20th century. It was thought that Ohm's law would fail at the atomic scale, but experiments did not borne out this expectation. As of 2012, researchers have demonstrated that Ohm's law works for silicon wires as small as 4 atoms wide and 1 atom high. So it is less fundamental than the Maxwell's equation and is also not always obeyed. So any given material will break down under a strong enough electric field, and some materials of interest in electrical engineering are non-ohmic under weak fields. Temperature effects. Ohm's law has sometimes been stated as, for a conductor in a given state, the electromotive force is proportional to the current produced. That is, the resistance, the ratio of the applied electromotive force or the voltage to the current does not vary with the current strength. The qualifier in a given state is usually repeated as meaning at the current constant temperature. Since the resistivity of the materials is usually dependent, because the conduction of the current is related to Joule heating of the conducting body, according to Joule's first law, the temperature of conducting body may change when it carries a current. The dependence of the resistance on temperature therefore makes the resistance depend upon the current in a typical experimental setup, making the law in this form difficult to directly verify. Maxwell and others worked on the several methods to test the law experimentally in 1876. Controlling the for heating effects. So the qualifier in the given state is usually interpreted as a meaning at a constant temperature, since the resistivity of the materials is usually temperature dependent. Resistors are circuit elements that impede the passage of electric charge in agreement with the Ohm's law and are designed to have a specific resistance value R. In schematic diagrams, a resistor is shown as along a rectangle or zigzag symbol. An element that behaves according to Ohm's law over some operating range is referred to as ohmic device or an ohmic resistor, because Ohm's law and a single value for the resistance suffice to describe the behavior of the device over that range. So, in schematic diagrams, a resistor is shown as long rectangle or zigzag symbol. Ohm's law holds for circuits containing only resistive elements, no capacitances, no inductances, for all forms of driving voltage or current, regardless of whether the driving voltage or the current is constant DC or time varying such as AC. At any instant of time, Ohm's law is valid for such circuits. So Ohm's law holds for circuits containing only resistive elements for all forms of driving voltage or current, regardless of whether the driving voltage or current is constant DC or the time varying such as AC. At any instant of time, Ohm's law is valid for such circuits. Ohm's law in the form above is extremely useful equation in the field of electrical or electronic engineering, because it describes how voltage, current and resistance are interrelated on a macroscopic level. That is commonly used as circuit elements in an electrical circuit. Physicists who study the electrical properties of matter at the microscopic level use a closely related and more general vector equation, sometimes also referred to as Ohm's law, having variables that are closely related to the VIR variables of Ohm's law, but which are each functions of position within the conductor. Physicists often use this continuum form of the Ohm's law. Applications of Ohm's law. When the other two numbers are known, Ohm's law may be used to determine the voltage, current, impedance or resistance of linear electrical circuit. Main applications of Ohm's law are: it also simplifies power calculations. To keep the desired voltage drop between the electrical components, Ohm's law is employed. An electrical circuit's voltage, resistance or current must be determined. Ohm's law is also utilized to redirect current in DC ammeters and other DC shunts. Ohm's law in the above form is an extremely useful equation in the field of electrical electronic engineering, because it describes how voltage, current and resistance are interrelated on a macroscopic level, that is commonly as circuit elements in an electrical circuit. Physicists who study the electrical properties of matter at the macroscopic level use a closely related and more general vector equation, sometimes also referred to as the ohmic law. Limitations of Ohm's law. The law of Ohm does not apply to unilateral networks. The current can flow only in one direction in unilateral networks. Diodes, transistors and other electronic components are used in these sorts of networks. Nonlinear components are also exempt from Ohm's law. Nonlinear components have a current that is not proportional to the applied voltage, which implies that the resistance value of those elements varies depending on the voltage and current. The thyristor is an example of a nonlinear element. Resistor. One of the most important components in electrical circuit is the resistor, because they are comprised of clay or carbon combination. They are good conductors and good insulators. 4 color bands are seen on the majority of resistors. The first and second bands show the values first and second digits respectively. The value digits are multiplied in the third band and the tolerance is determined in the fourth band. If there isn't a fourth band, the tolerance is presumed to be plus or minus 20%. Resistance in series. A series is a group of related items such as long as line in a row or in a certain order. In electronic series, resistance implies that the resistors are linked in series and that the current can only travel via one channel. Resistance in parallel. A parallel circuit can be organized in a variety of ways. The majority of wiring in this world is done in parallel, such that the voltage provided to any one portion of the network is same as the voltage given to any other section of it. Laws of series circuit. The overall circuit resistance is made up of individual resistances. The total voltage is the sum of the individual voltages in the current circuit. Every point in the circuit has the same amount of current flowing through it. Laws of parallel circuits. All the components' resistance is reciprocal adds up to the overall circuit's resistance is reciprocal. The total current drawn in the sum is the sum of individual current pulls across the circuit. Every point in the circuit has the same voltage. Thank you, sir, for giving me this wonderful opportunity of sharing my views.